Just south of Lincolnshire here in the UK, near the Waddington or Watto RAF base, we have an unassuming industrial building with the number 20 on it. And it's 3D printed. We're here at CONSTRUCT3D rolling a Nat 20, where we're gonna take a look at what it takes to make the UK's fastest 3D printer. So let's go do this, MTV Crib style. Hi.
No.
No?
Hey, Graham.
How you doing?
It's late.
It is late. Yeah, let's,
I'll put the kettle on. Do you want a cuppa?
a couple what?
A cuppa.
A couple what?
A cuppa.
We're in CONSTRUCT3D!
Welcome.
Thank you.
It's really good to have you here, to be honest.
Dude, it's been a long journey. We're glad to be here, and I'm excited because I hear a lot of good things about you all. You have the world's first bamboo 3D printer, you got the fastest 3D printer in the UK, and you got some new hotness that we want to take a look at too. But I want to first get an idea of what's going on here, and I'm told we got to go upstairs first, right?
Oh yeah, we can't take you to the good stuff right at the start. So going upstairs, we have a mezzanine. So a bit of background behind the building. This was a completely empty factory lot.
Like,
completely.
bare.
It was bare. No paint on the walls, no lights on the ceilings, no electrical panel in the wall. We had to put all of it in, build it up ourselves, and put everything here. We actually had quite a lot of bad advice about not doing those sort of things and just getting to production straight away, but we needed it.
Yeah,
like
no,
the
you
amount
have
of
to make
stock
sure.
you have and the amount of extras that you just need to keep in one area meant if we didn't do it, we wouldn't be here right now.
You've got a nice little setup here.
Thank you.
Conference table, couple of machines. Are these the Construct 1XLs?
Yep, these are our 1XLs.
The nice piece of bamboo on the side, flex plates and everything.
So these are our demonstrator machines.
Okay.
So this entire area is actually normally for training.
Okay.
So certain customers might have either never used a printer before, or they are more unsure about the entire process of repair, maintenance. Like the more industrial side normally comes to this area here. So we'll sit them down, we'll run them through everything, we'll teach them up the basics, basically just showing them your YouTube videos in a written form. And then we'll get them working on the machines themselves, and we'll let them strip them.
You know, you got a little hangout area, but I see something that tends to catch my eye other than, you know, the big print on the table, which we're gonna...
If you recognize this,
Let us
we're
know.
working on it.
Yeah, let us know in the comments if you recognize it. We got this table with benchies.
Yes.
You got a thing for the tugboats that are your actual drawer pulls for this, which I find pretty funny. It's a bit of tip of the hat to 3D printing. And
Well, we've literally made thousands of benchies. When we're calibrating a new machine, I think we've hit about 2,000 so far.
that's a lot of benchies.
Well, every machine we make makes at least 2.
Okay.
And then any machine we test or we're doing a new development for, we'll be running hundreds of iterations. And at the end of the day, a benchy is a good compliance print.
And so we've got another XL over here, right? This is the one behind you. That's
Yep.
another Construct 1XL.
So this is actually the one, it's a really early serial number that was made for the manuals. So in the manual, we have QR codes for how to repair certain bits, replace certain bits. After all, a YouTube video is a little bit better than written words.
I think
and
so.
The British tend to be a bit wordy in the manuals.
Would have never guessed.
A video can go 1,000 more words in a lot shorter time. So this is actually where we record most of our unpacking experience, our how to fix certain parts. That was all done here.
Nice.
Whereas all of our more short form content or little things like how to look at bed level and all of that, I straddle a camera very badly because I'm not a YouTuber, and we film it all here. So you just have 2 floating hands in front of a really nice background.
There's more up here, right? There's a print farm. I want to check that out, right? That's where the magic happens. Although I hear the magic's really downstairs in the prototyping area. But you got a print farm to kind of test and prove out your machines before they go out to customers, because especially as a 2-person business, you all really need to make sure that these machines that go out don't come back for repairs, because that is costly.
The time cost when we're so small is actually a lot larger than if we were a larger company. So at the end of the day, if one machine comes back, that means we cannot do anything else because that becomes priority number 1. So the print farm's actually relatively small. We don't need a massive print farm for the amount of throughput that our machines make. As we are the UK's fastest, they produce a lot more parts per unit of time than most other machines. If this was any other printer company, we would need a much larger area. But also, it means we can validate iteration changes as we go. So we've got some of the very first printers, literally this one went to us to Malta.
This was the printer in Joel's video.
Yes.
That's pretty cool.
And it's still working.
Joel.
It is honestly still working strong. And that's what we like about them is A, we get to see which parts fail first.
Right.
And then we can monitor how they're starting to like degrade over time. So the next iteration, we fix it, we make it even more robust, because at the end of the day, we don't want people coming back to us. We want a very good experience of just it works. Where if a machine breaks, it costs us a lot more than your frustration, which is also a bad thing to have.
Yeah, you probably don't want a Grant rant, I assume.
Oh, no.
Right? Yeah. Those videos get good views though, so.
Well, I can't give you a fire printer that catches fire because they're also self-extinguishing, because we go that far to test.
Yeah, you all are pushing for full UL validation, aren't you?
We've actually already passed all of UL standards.
And this is not the green UL, this is like UL.
Yeah, this is no green guard, this is no emission testing, this is straight up UL on every component. And part of that is actually every component has to be UL like tested in the first place. So every sub-component is already passed, then we build the machine, and then the machine has actually already passed all the tests. We just need to now give it to UL to finish that process.
Nice.
Safety from a compliance point of view doesn't stop at a piece of paper. It starts before then.
That's right. Feels like I'm at home, right? It's nice and tight between the different racks of machines. I've always wanted to do this with the racks that we have. Just encase it in extruded aluminum, put doors on it so you're able to keep the temperature control, and you can work on testing like high temp stuff, which may or may not be something that you all need to know in just a few minutes, so stay tuned for that. I know the magic, the new machine, the CONSTRUCT2, is downstairs.
Oh, it is.
Let's go take a look at it, come on.
So following on to the right is the start of the production line.
No. This is
What do you mean,
MTV.
no?
This is an MTV crib style video. What do you have to do? This is the kitchenette. We gotta look at the fridge.
The fridge.
Yeah, I know. You gotta see what's in the fridge. You know, a micro cooler, if you will. I think it's perfectly normal, but micro cooler and.
It's average sized.
Wait. Why are there dice in the fridge?
The dice are too hot, so we got to cool them down all the time.
These were the dice that we used to pie me in the face at Smurf. If you do want to watch that, we'll card to that stream so you can take a look. Don't throw. Okay. Day one, they were rolling 20s and 6s like it was going out of style. It was a messy couple of days. Anyways, you've got granite fixture plates in here. You're building machines on granite plates. Why do you have this? Why is this necessary?
To start with, these are 00 gauge fixture plates, so they're lab grade. They're not workshop grade. They're one grade higher. It's mostly for making sure that when we build it, it's on a consistent, stable surface.
You want to experience true level? Do you?
If you've ever built on like an MDF plate, or even if it's thick, or it's even a steel one, there's actually quite a lot of deviation in the surface.
Right.
We need to guarantee the machines were made square, so when they warp in the future, because whatever table they get put on, it will warp, at least we can guarantee it's square to itself, so as it warps, it stays smooth. Otherwise you can get binding and there's other things going on.
You got a lot of inventory here, it looks like. We have extrusions and parts to build the machines themselves.
Quality control starts before they even enter the factory. So it's which supplier do you go with, what type of cut surface do you go with, even the design. So if you can design it so it's easier for an external source to manufacture, that means you don't have to do it yourself and possibly add a failure point. Because at the end of the day, if a company has spent their entire lives making one thing, why do it yourself when they're better than it than you?
You're not just buying the random extrusions off of AliExpress like the rest of us?
Oh no.
I mean,
these are custom. For example, let's take a leg. So we have custom holes drilled into it. We have milled slots in some of the extrusions. When you machine a slot into stuff, it self-aligns. And we need to reduce the amount of man hours because English labor is quite expensive. So by doing good design at the start, we can alleviate a lot more costs down the line, as well as making them faster and easier to maintain.
How many hours do you think that you have in just the frame design alone?
I couldn't say for hours, but I know the version number. We hit over 300 iterations of the frame, the design, how the bolts go together, and then how it's assembled.
So you've really taken attention to detail to make sure that every single machine that leaves your factory is not only safe, it's square and sexy?
Ooh, I like that.
Maybe.
Well, I've got a test for you. I prepared something in advance. Here is an empty machine frame. It has been built on the granite surface.
We have movie magic, so I can just, BAM! There's a printer. Isn't that cool?
I don't like that one.
I mean, it's not as cool as yours, but I did it.
Well, get rid of that.
Okay, all right, we're gonna take it and, what the heck do I need to do? You didn't tell me there was gonna be a test.
Run it steady!
I want you to look at this frame and determine if this is a quality pass or a quality fail.
What tools do I get to use?
You.
Can I use this? This was on the
Yes.
table. I'm using this.
You may.
Oh my God, this thing is heavy.
Oh, they have to be precision ground. If they're not square, you can't use them.
Well, I mean, it is hip to be square, isn't it?
And if that's not good enough, we also have big one.
There's no way that's more accurate than this.
You'll be surprised.
I'm going with this one. It's not as hard. All right, so I gotta test angles here, right? Or looking for angles. I don't know what I'm looking for. It doesn't pass. I can immediately see it doesn't pass.
Nope, it
Yeah.
doesn't.
Yeah, back here. This is not a 90.
No. But
Where else doesn't?
this side is low by 0.5 millimeter.
Well, how did you think I was gonna? I don't have any scanners with me today. It's low. How do you measure that?
Lots of trial and error. We strip the machine, put them back on the granite so we can actually test for flatness of each extrusion,
Okay.
and then for twist as well.
Okay.
So once they pass all that, they then get graded. So A, B, and C. C goes to recycling, B gets used internally only, A goes out to customers.
Okay.
This is a grade C frame. It doesn't even pass my internal, I don't mind a bodge machine, like quality standards. This will never hit a customer shelf because we check every single extrusion.
So what happens to it?
Recycling. We might chop it up into smaller sections to be
Okay.
recycled into others, like the extrusions themselves can then be topped and tailed and then turned into the smaller machines frames.
Okay.
But other than that, if they are warped, bent, twisted in any way, unless I'm using it for a personal project, that's going straight to recycling. We take quality control here very seriously.
Yeah, obviously. I mean, this is a non-trivial amount of money, but quality has a price.
Let's take you further on. So this is a more built-up machine frame. This
Okay.
has gone probably past the 60% assembled part.
Very nice.
Normally we like to run a one machine per builder.
Okay.
So there is me, my dad, and my mum that
Okay.
work inside the company. I've only recently brought Dad in.
That's
so,
literally it.
Yep, that's us at the moment.
So it's literally a family-run business.
Oh yeah. This
Family
one's
owned and
actually
operated.
Dad's machine that he's been building. Now
Okay.
it will be signed off by 2 people at minimum. So there is a 2-stage quality control. So if somebody misses something and just keeps missing it as they go along, which humans do, then the second person comes along and they will do the entire checkout process the entire way through to make sure it was built the exact same way as it would be built to every other machine. For example, let me reach over here, the engineering Bible. This is everything you need.
This is not the McMaster car book.
Oh, I wish it was.
Assembly instructions.
This
okay.
is every instruction you need
That's,
to build the machine. Every step is laid out in almost an IKEA form of how to build a machine. Every design step that needs
Wow.
something tweaking has been done by me externally, and then it comes into this. So if we ever need to expand very quickly, you can take somebody straight to the production floor, give them the Bible, and then they can start production straight away. Everything from little quality checks that they need to ensure to mandatory quality checks that you need to triple check that this is within a certain tolerance. It's all within that book.
I mean, this is what repeatability looks like, because obviously you don't want to be building machines the rest of your life. Your mom doesn't want to be building machines for the rest of her life, and your dad didn't probably sign up for this at all.
Oh, no.
You just dragged him in.
He got press ganged in. I was sick one day, and now he's enjoying it very much.
This type of documentation is really important, something we don't see in many small businesses that are 100 times your size, let alone down to 3 people. This takes a lot of time, but it ensures that you can continue to make good products in the future. So that's really, really cool. I'm impressed because this was a lot of work. I'm upset because I don't have something as nice as this, and I'm worried because you're gonna run out of space with documentation this good
Oh, yes.
when people see this new machine that you guys are doing.
I think the book is about twice the size so far.
Oh no. Well, let's see what else is going on. I see we've got Mom here. She's hard at work making sure that everything that you get wrong is actually fixed and done right. It appears that, at least somebody here knows what the heck they're doing. So, how you doing?
I'm good, thanks. How are you?
Oh, we're doing great. It's a little chilly outside, and I still haven't figured out what a cuppa is and what I'm actually going to get in it, but
Don't worry, you win one at the end for passing the test.
I'm afraid now.
So we go over to extruder assembly. So we buy in a lot of our parts from better, more established manufacturers than if we could redesign it ourselves.
Okay.
At the end of the day, we are a new company, and being smart is being aware of your shortcomings. So utilize the experience of others up until that you've gained that experience yourself. That doesn't mean we don't quality check every single one, just to be certain, because that's part of what we do. We want to be the one that guarantees every single machine works when it arrives. There should be a 0% failure rate. At least that's the goal.
The goal is always 0%. And we got a little baby one here.
This one actually just went to Smurf. So this
was one of them
This
at
is the Smurf machine.
Nice.
It's literally 3 years old, works day in, day out. Obviously not at the moment because the factory is tired and shut from Smurf. But this is
I'm not
what
keeping
makes
you up,
most
mate.
of the parts. And if she doesn't run it every single day, we don't make parts. And if we don't make parts, we don't make printers.
You said she.
Oh yeah, every machine's named.
What's this name?
Eliza. Well, when every machine looks the same, and they work pretty much the same, because they are all very high quality, the only way you can differentiate them is a name.
Yeah, and when you're slowly going insane, you at least have something to talk to. Let us know in the comments what the names of your machines are.
Then it's just bamboo storage. So everything, again, gets graded. These ones were now cut locally. We did do an external cutting service, but now we've gone to an actual local maker. Because most makers do a better job than bigger companies.
You ain't lying.
I know.
It's like makers care way more. They put their blood, sweat, and tears into it, and that's really cool to see that you guys are sourcing stuff locally when and where you can, so you're maintaining as much made here in the UK as possible. We like to support Made in America, obviously, so it's really cool to see that you guys are supporting Made in the UK.
Plus, it's a nice bit of analysis. It costs a bit more to go local, but then you save more in the long run because you have less failures.
Yeah.
And trust me, the first batch we had almost a 50% failure rate. Not because of the wood, not because of the processes, but because once they were put in the box, they were slightly wet.
They warped.
And then we can't use them. So
Did you mill them into very thin cutting boards for family members?
Oh,
or
I was
something?
very tempted. I mean, the coating is food safe after all, so.
Of course it is. Why
Dog
wouldn't
safe
it
as
be?
well, because you got to be careful of that. I like to say we're paranoid about safety. Everything that comes first is reliability and safety. Everything after is free. And it just so happens speed, quality, reliability that makes the machines what the machines are just a byproduct of doing something right first time.
Can't debate that. I mean, I don't always do it right the first time, but we do our best to make it right in the end. Speaking of making it right in the end, we've got some new hotness over here. This is what we saw at Smurf, where we teased that we'd be showing this off in quite a bit more detail. This is the brand new Construct 2.
Yes. So this is sat on our testing bays because it is being tested. It is a much faster, not in terms of high speed, it's the same top speed as our last printers because it's not a replacement for our last printers. It is a different class. They don't fight each other. So Construct 1 and Construct 2 are not the new versus the old. It's this sector versus this sector.
Okay.
Construct 1 is a generalist machine. It does everything very well, but not the super high end of polymers.
But this machine, as you told me, can get a little bit hot.
Yes, so this is a 75-degree heated chamber. It has double the flow rate of last time. It is currently being feature equipped for an upcoming filament changer add-on later down the line. It has complete air gap ability. So one of the sectors we're aiming this towards is obviously more heavier duty industry, but that also includes a lot of military sides, as they don't have many options. They keep asking us if we can do something. This is how we do it, by doing it properly first time. So Wi-Fi and Ethernet as standard, but if they don't want that, because they want to be fully air gapped, it can run completely headlessly. On the front, we actually have 2 USBs and a HDMI port, so you can plug in a keyboard, a mouse, and an external monitor to get all the online functionality held locally within the machine.
I'm seeing some real beefy components used in here. I mean, real thick motors. We've got big aluminum extrusions, double linear rails on the x-axis. Why double linear rails on the x-axis?
Rigidity and tolerancing.
Okay.
So with one linear rail, you get a little bit of side slip. So it's normally RY, RZ, and RT, which are the type of tolerance, like creeps you get in those parts.
Okay.
Basically means roll, twist, and yaw of the part. Anything that you put inside something, it will have a bit of slop. Otherwise, it's stuck, and you don't want a bearing to be stuck.
Yeah.
So by adding 2, the distance eliminates pretty much all of the slop in that system, allowing you to push faster, push harder, and push more reliably without messing up the entire system.
I don't think I've ever seen a company do that before, using really wide belts. 9 mil belts?
9 mil. 9 mil high
belts
temperature belts.
From Gates?
Yep, official Gates only. We've tried a lot of the, I'm not going to call them knockoffs, but alternatives, and they don't come close to performance.
You are going to trigger Steve Builds, though. When he was telling me how to belt a Voron, he said, you need to make sure that the logo's the right side up. So Steve, that one's for you. But can we talk about like the build volume on this machine? Because it's a big machine.
Oh, she's big, that all right. At the moment, she's at 335 in the X, 390 in the Y, and 400 in the Z.
That's a really
Fully
big printer.
equipable with up to 5 kilo spools on the inside.
Can the bed handle 5 kilos though?
Oh yes. So part of the design side
big part too,
is knowing how to put certain components in situations that they're not normally designed for. In this case, most motors don't have the right bearing stack on the inside for higher weight, higher temperature applications.
Right.
Well, the temperature's an easy fix, get a better grade of motor. But that doesn't mean the weight category is fixed. Turn it external. Put all the bearing stack that needs to have the compression load outside the thread, not inside the motor. And then you can tolerance that in, guarantee it's built correctly, because you're basically making your own custom motor at that stage without redesigning the wheel.
There's a lot going on here, obviously, Jacob, but what is the most unique thing on this printer?
I'd say one that catches people by surprise is the gravity-fed bed. It is completely decoupled.
Oh, no. What? How? What?
The bed is completely decoupled from the Z motors, and that allows it to thermally stabilize itself without causing any form of Z banding. It's one of the things that make us as high quality as possible, because there is no influence of the threaded rods against the bed to cause any form of Z banding or Z shadowing. Also, it's really easy to maintain.
I was talking about the tool head, that it's completely special and different. I didn't even know about that.
Well, you get used to things, so I thought that was mundane.
I get used
to
you pulling surprises on me. We've definitely not Rachel Rayed an entire hot end assembly here, so you can see what it looks like. You are resin printing these currently.
Yes.
But we're going to be messing around here soon with some different materials, so stay tuned for that as we, have a little bit of extra fun. But this is a proper tool. I'm looking at a roto. I see a Duet eddy current sensor. We've got the Duet board that works with Duet and roto. And how did you do this? This isn't an E3D hot end, but it's an E3D extruder, and it's what?
So there's some custom machining going on. So going from top to bottom, we've got a flow rate sensor. That allows for the printer to actually compensate for under extrusion events, but also if it jams itself. It's a very nice way to also gather data about under and over extrusion. Obviously E3D roto. It's nice, it's lightweight, it's fast. But then that's really where the stack traditionally ends. You go to what's normally a Revo block, and then that's your printer done. Revo, for our application, does not have a high enough flow rate, because we are trying to max out the machine on every category. So we had to go custom. So we've made a custom hard mount adapter, which is this little bit right here.
I don't think I've ever seen someone do something like that before.
We needed a way to hard mount a Voron/Feta style 4-bolt like hard mount to what is traditionally just a single heat break into what would be a V6 or a Volcano block.
Right.
They didn't exist. But there is enough surface area on the part to make a very simple insert that then converts to a flange, and then the flange can convert to whatever you need it to be.
So there's not just metal 3D printing, which that's an E3D thing. You did custom machining of the freaking hot end so that you could take the extruder that you wanted and the hot end that you wanted and, you know, get them a little bit more comfortable with each other.
Well, part of knowing when to design something versus when to buy something is literally about what requirements do you have versus what do you need to do to make it happen.
Okay.
For a business, the best thing you can do is off the shelf.
Right.
Because there is an ecosystem that already exists and there's quality control that's already in the pipeline before it even hits you. So the risk is very low. But that means you're also limited by what choices are available.
Okay.
I don't like limitations, and this machine certainly doesn't like limitations, so you have to go custom. So we've been able to make one part that makes the entire thing a vertical stack of whatever we choose.
So looking at this thing further, there's a lot going on here, and you've decided to put it all into a nice little button. You've got a massive fan that goes on the front of it, and not a whole lot else.
You don't need a lot else. So cooling fans, for example, you're moving the head so fast, you're going to be outside the molten zone pretty much instantly, meaning you can't rely on the cooling fan of the hot end to cool the part.
Right.
You have to rely on a bed cooler instead. So we've got 4 massive 120 millimeter fans.
4?
4 of them, yeah. And each quadrant of the machine has its own bed cooling zone.
Dang.
So you can guarantee no matter how fast or how thin or how much heat you put in a part, you can evacuate that. The rest of it is a massive cooling fan on the front, so it can cool the entire stack, including the motor, the daughter board, and the hot end all in one go.
Okay.
And then the rest is just keep it really simple, because things don't break if they're simple.
Simple is often good. I mean, that's Occam's razor. But this is the definition of not Occam's razor. You tell me that simple is good, and yet I'm looking at something that is abysmally complicated. But I'm also terribly in love with it because it's complicated for all the right reasons. You guys decided that you didn't want to cut corners. You wanted to build the best machine that you possibly could. Say, the price is going to be what the price is going to be. It's designed after industrial applications. Anyways, it's got a chamber heater that can go to 75°C, a bed that can get, according to the steel sheet, 120 freaking degrees Celsius, and a hot end that effectively allows you to go really as hot as you want.
Oh yeah.
This is a machine that is squarely positioned at light industrial or even heavy industrial for a whole farm of them.
Oh yeah. The entire idea was, if it has to be a standalone system, it has to also work with other machines.
Right.
So if you have 50 of these in a line, they have to work with each other.
Okay.
So we have a lighthouse system on the inside. So the color when the lights turn on states what state the machine is in. So you can see from a glance which machines need attention, which machines don't. Are they ready? Do they need to take parts off, or does it need filament being put in?
That's literally one of the things we talk about that industrial machines have. They have the little nacelle. Well, you don't have the nacelle. You've got lights that do the same thing. It's that visual representation of, are you angry, are you waiting, or are you happy, right? Damn, that's brilliant. You guys you've set a bar here. I'm a little bit worried for some of these other companies that are looking at the work that you're doing, because I don't know if they're going to be able to compete. What is the estimated retail price? This thing is still a little bit away from going out to even pre-orders, let alone delivered units. What are we looking at potential estimated retail price?
So far, we're looking at about 8,500. We're going to do a small production run at the start.
Okay.
We're going to work very closely with the people that buy to make sure it's a really good experience. We're looking at most 100 units to produce and then ship out.
Okay. Yeah. And that's just kind of the start to make sure everything is good.
Yeah.
And obviously upgrade as needed. That's really awesome. I see there's only a few printed parts in here. There's some SLA, but
where it makes sense, we will print. Where it doesn't, we will traditionally manufacture. Part of good design is knowing where that line is, because when you have a printer, everything looks printable.
Yeah.
And you need to choose the right time to use your tool, not because you like the tool the most.
3D printers are tools, they're not solutions. I always appreciate when someone else understands that too. Jacob, I really do like this machine. I think you and your family are kind of setting the bar for not just consumer grade machines, but really looking at what we can do on the industrial scale as well. I am very excited to see what happens with the Construct 2 as it continues down its development cycle. But seeing it print at Smurf gave me hope that we can see a proper small business industrial grade 3D printer that isn't going to damage my wallet too much, because printers in this basic, size category often have like another zero at the end.
She's not the cheapest.
No,
but we don't aim for that.
No,
we want it to be a good deal.
Right. It is a good deal when you look at the competition, like from the, other companies out there who will remain nameless. Guys, I'd love to know your thoughts on not just the Construct 2, but the entire thing here that we've seen at Construct3D, from literally family owned and operated to the first bamboo printer and the fastest 3D printer in the UK. I'd love to know your thoughts, and what's your favorite feature on the Construct 2? Because we'd like to look at profiling some certain things with Jacob, his mom and his dad here in the coming few months. But that is all we have for you all today. Make sure to leave a like and get subscribed. Stay safe out there. Don't forget to call your loved ones. And as always,
keep making awesome.
I didn't even have to tell him to do that.
I'm good at this. Now get out.
No, what?
No, out.
I want to stay here.
Come. There we go.
But no, I like it here.
This is my factory. You've been banned.
Well, you can't ban Florida Man.
You have too many benchies in your bag.
I don't have too many benchies.
There you go. Open the door. Come on.
No.
Open. It's this way. Come on.
Come on. No.
But come.
No,
There
I don't.
There's your cuppa.
Cup of what? What's in this? What? No.
That's going in an outtake now. I mean, this is literally having a cuppa. Like sitting down and just having some fun.
And in some places
It
they
is,
call
isn't
it
it?
a cup of char.
A cup of char?
No, nobody calls it that.
Londoners call it a cup of char.
Yes, but we're not Londoners. We're up north.
And if you're really,
I know,
really,
we're northerners.
if you're really posh, you would have to hold your mug in the right way as well. With
Go on and pinky up, yes. Cheers.
Cheers.
You meant to bend it.
Meant to bend it? Oh, I'm
Yeah.
sorry.
Yeah, if it's too straight, that annoys the internet.